Hi friends, welcome to the class of engineering mechanics. Till now we have seen CO1, it is friction forces, resultant of forces. CO2 we have seen trusses. Okay, in CO3 we have seen moment of inertia and friction, correct? Now today we will talk about CO4, that is dynamics and kinematics. Means there will be some motion. Okay, how the motion will be there, what are the things that we will see. Dynamics, here you can see the water is moving, it is dynamics, movement of water. Now as I told you, classification of mechanics, mechanics of solids, mechanics of fluid. Again mechanics of solid, there is rigid body, there is deformable body. Now again in rigid body there is static and dynamic. Till now we have seen static, there was no motion. Now dynamic, there is motion. Okay, so in dynamics there is two things, kinematics and kinetics. We will see about kinematics and kinetics part. Okay, now dynamics is nothing but the branch of mechanics which deal with forces and their effects on the body where there is a motion. Till now we have not seen about motion because it was static. Here you will see motion and forces, all the things together. So there will be velocity, there will be acceleration and everything. Okay, now as I told you, there are two parts, kinematics and kinetics under dynamics. What are those things? Kinematics, here we talk about motion but without the forces. Kinetics, we talk about forces as well as motion, both things. So where in the first thing, a stone is falling from top of building. Okay, we will not see the force, we will see only motion. In second thing, persons are pushing the car, so we will see motion as well as the force applied to move the car. Okay, types of motion, translatory means cycle is moving in a straight line, rotation, something is rotating, plane motion, motion about a fixed point. For example, earth is rotating about something, so something is rotating about fixed point, correct? Plane motion means in one plane, this carom board, the coins and the stagger is moving in one plane. Okay, there are different types of motions. Now linear motion, parameters, what are the parameters required for a linear motion? A displacement, initial velocity, a final velocity, a time interval, a time taken to travel, and the acceleration. Okay, these are things required for the linear motion. Angular motion, here also same thing but in angle. So in place of displacement it is angular displacement, in place of velocity it is angular velocity. In the same way, a time interval is common, acceleration here angular acceleration, and notations are also different. In previous case notations were displacement is represented by s, initial velocity u, final v, time interval t, constant acceleration a. Here theta, omega 0, omega and alpha representations are changed. Here there are things in radians, there it was in meters. Okay, the difference, how you will correlate linear and angular parameters. So s equals to r theta. S is displacement, theta is angular displacement, r is radius. So there is a term of radius or distance you can say, which will convert linear and angular. Okay, v equals to r omega, a equals to r alpha. Okay, everywhere there is a r distance. These are some equations of motion. You know, v equals to u plus at, v square minus u square equals to 2as. Okay, all these formulas you know, s equals to u2 plus half at square. Those things are for linear motion, same things are represented by for rotational motions. Okay, now this is one problem. Let us solve this problem. There is a time, you have to determine the time and distance traveled by the car. How much time, how much distance traveled by car. You are given acceleration and velocity. Such kind of problems you are going to solve. These are real time exciting problems, my friends. Now kinetics of rigid body. Okay, what is happening? A ball is rotating. What are the forces acting on it? That we have to see. mg is a force acting in vertical direction downwards. G is center of gravity. Downside normal force by ground on the ball. Then because it is rolling, there is a friction force. Force P, external force is acting on it, and it is rolling, so there will be omega, angular velocity. Okay, so many things are there. This is case of rigid body. Okay, here also football is there. We are applying force, it is moving. We know F equals to ma. Correct? This is a relationship. This is nothing but Newton's second law of motion only. Okay, it is used here. Now equation of motion for linear motion is nothing but F equals to ma. Simple, you know. Now motion in rotational. For rotation it is I into alpha equals to summation of m. Summation of f m is nothing but moment, and I is nothing but moment of inertia about axis of rotation, and alpha is angular acceleration. So summation of m equals to I into alpha. Okay, here how to find omega? It is d theta by dt. How to find alpha? D omega by dt. Okay, now different kinds of problems which you will study here. A pulley having load. Okay, a box which you are sliding by applying the force. Okay, now D'Alembert principle. This is one of the most important theorem here. For it is, you can see here summation of force minus ma. Ma is nothing but force due to inertia. Force due to inertia is represented by ma. You was knowing the formula F equals to ma. Now you are bringing ma and F on one side, and you are doing summation of it. Summation of F minus ma equals to 0. This is nothing but D'Alembert principle. Very small, basic. Okay. Now similarity between second law of motion and D'Alembert principle. As I told you just now, summation of F equals to ma, summation of F minus ma equals to 0. Means in second law there was product of mass and acceleration which is equals to force, but here what is happening? Force you are subtracting with m into a and equating it with 0. So almost same, only just you are playing, transferring one thing from one place to another one. Okay, so you are calling fictitious force. That fictitious force is nothing but inertia force, m into a, and in reverse direction. Okay, here you can see a bullet is there having mass m, moving with acceleration a. When you are applying a force F, so you are getting an inertia force in opposite direction, Fi. For example, lift. When you are moving in lift is going up, feel a force downside. Now these are some examples how to solve D'Alembert principle. Okay, we will this is about rotational motion where D'Alembert principle is required. I alpha equals to m. Correct? Previously F equals to ma. Now here I alpha equals to m. Okay. This is one of the example again. One block is on horizontal, another is on vertical, hanged with the help of rope through one pulley. A wedge sliding. These all are examples which you can solve. Now coming to work. What is work? What is work done? When a force causes a body to move, work is being done on the object by the force. Okay, work is nothing but measure of energy transfer when force F moves in any object by distance s. You can see here expression of work done. F into ds, force into the displacement in the direction of force, which will give you work done. SI unit of work is joule, which is nothing but force into distance. Force is Newton, distance is m, so Newton meter. Same thing. Now here we will see force is acting in vertical direction, upward direction, but displacement is on the horizontal direction by yellow color ds. So work done will be 0. Why? Because force is in another direction and displacement is in another direction. So what will happen? Work done will be 0. My dear friends, again I will tell you, work is nothing but force into displacement in the direction of force. Here force is opposite, in perpendicular 90 degree to displacement, so work done will be 0. In second case, displacement is at some angle, so you can resolve this. You can resolve the component of delta S into horizontal and vertical, so we will get some work done, it will not be 0. Same thing in third case. Okay, now energy. What is energy? The ability to do work is nothing but energy, correct, and its unit is also joule. So unit of joule, energy and work both are same. Okay, now energy is of different types. We know kinetic energy and potential energy. Kinetic is due to motion or velocity, you can say. Potential is due to height, okay, or due to altitude. Now principle of work energy. What is principle? The net work done on a body is equal to change in kinetic energy of the body. This is known as work energy theorem. Means somewhere you are relating work with energy. Okay, so you will get F into ds, which is work equals to half mv square. Half mv square is nothing but kinetic energy. So initial kinetic energy and final kinetic energy difference. This will give you work done. This is principle of work energy. Momentum, mass into velocity will give you momentum. Momentum is also important thing. Okay, it is represented by P. Now impulse, it is another factor. Impulse is nothing but force for very small time interval will give you impulse. Force, large force for a small interval of time. When you are hitting a ball with the bat, the contact period between bat and ball is very small, but force applied, you are applying very much force, power. Okay, so force into is very small time will give you impulse. Now there is another theorem known as impulse momentum theorem. The change in momentum is equal to impulse. Change in momentum is equal to impulse. Okay, so these are some problems you have seen here. Baseball, cricket, here you are hitting a football, the shoes, all these are the examples. So thank you dear friends. Now I have covered a glimpse, a small, you can say, description about CO4 today. I hope all of you have enjoyed and it was very interesting. Okay, because here all are related to your real life situation. This is the mechanics, very much enjoyment. Okay, so we will meet afterwards in the next class. Thank you everyone.